So good morning, everybody. Welcome to the final presentation of these really amazing projects, which are Lovewear and Connextyle. My name is Joanna. I'm head of events at Wear It Berlin. And today, well, this morning, or depends which time zone you're watching us from, we're gonna dig a bit deeper into the topic of electronic textiles and fashion, and also just look at the results of these projects. And also have some short Q&As where you can ask questions in real time to our panelists. So we really encourage you to use the chat option or the Q&A option. Just ask your questions. And we have here my colleague Anish. He's gonna monitor the chat the whole time, and he's gonna direct your questions to our panelists. So just to give you a bit of an overview about Re-FREAM, Re-FREAM is a research project that invites artists and designers to connect with scientists and find common ground so that they can then rethink the manufacturing process of the fashion industry. This whole project is based on the idea of co-research and co-creation. And the selected artists and technologists, they commit to a 9 months period where they work partially face-to-face, so in person, and partially online, and to a co-research and co-create process together while using Re-FREAM's art and tech collaboration methodology on specific challenges. So we have in total 3 challenges all over Europe. And artists and designers are asked to rethink their work in a more scientific way. And on the other hand, the scientists are required to rethink their research in a more artistic way. So in the end, both groups are really benefiting from this mutual learning and empowerment, actually. Also, I would like to mention that Re-FREAM is a pillar of the STARTS program and an initiative of the European Commission under the Horizon 2020 Research and Innovation Program. As you already know, the talks today are, or the presentations today are from two projects in Hub Berlin, where we focus on the integration of electronics into textiles, which enables new potentials of how we communicate in the future with each other, and also find basically new ways to interact between the human body and its environment, actually. As I already said, we have Hub Berlin. Hub Berlin is managed by Wear It Berlin. And today we have our CEO, Thomas Gnam, who is gonna give you a bit of an introduction about what we do.
Yeah, Joanna, thank you so much for the intro. The panelists know us already, but for those out there that haven't heard about us, we are a digital innovation agency, so to say. So our mission is really to bring digital innovation into the traditional textile industry, to enable them to become part of this new all-connected area. This new world, and the mission is to build ecosystems and really to bridge 2 different parts that together can form a new industry. We do this Varied Innovation Summit, a live event that's taking place annually. We have been doing it for 7 years. There's a LinkedIn group for professional exchange of industry participants. And recently, we have also founded a new kind of startup. It's called Boldware. It offers a easy to implement solution for the traditional industry. They can build it in its hardware into their textile products to become more digital, to connect their traditional clothing to web services and to make it digital and interactive. There's already a collaboration going on with H&M and also a shoe manufacturer, so we are really looking forward for this. And it's like taking the idea now to the mass markets, which is also exciting. But now, so in our experience, like networking, collaborations, and exchange is really key for developing a new product in this area. One player alone cannot do it in our perspective, and that's why it's so great to have Re-FREAM, because it shows like how a collaboration can take place under real conditions for several months, and how maybe what problems occur, but what solutions are developed. And it's really a good experience that shows people from the industry how their next steps could look like. And so my fingers are crossed for our teams that are going to present now. Looking forward for it. Thank you for your great work, and talk to you later. Thanks.
Thank you, Thomas. Yeah, so as I said, we have Hub Berlin. Of course, we have to also mention the scientific partners, which have a great contribution, which are Fraunhofer IZM. We have today Christian Dils and Marwede here with us. And you're gonna have the chance to also talk to them in the Q&A part. So just really ask questions, use the chat option also to introduce yourself. Just tell us a bit about yourself, what your work is focused on, and interact as much as possible. We really encourage you to do that. And we also have in Hub Berlin, we have EMPA, which is based in Switzerland. They also support our artists in the ARTE collaborations. Well, I hope that your coffee has already started to kick in, because I think we should already start. And we have the first project today, which is Lovewear by Team Witsense. This is Emma and Ivan, you see them already. Lovewear is a smart underwear which helps people of all abilities to self-explore and enhance their own intimacy and sexuality. And I would like now to give the floor to you and tell us about what happened in these last months and how the project evolved and what the results are.
Thank you, Joanna. Good morning, everyone.
Good morning.
Good morning. I'm going to share my presentation. So we are Witsense. We are presenting Witsense. We are a startup. We design and manufacture sensible, innovative products. We do something that we call sensible innovation. Our aim is to promote social inclusion through the use of technologies. One of our first projects were the SenseWear, a collection of inclusive garments and accessories that were including therapies addressed to sensory processing disorders. While working with disabilities and inclusion, we came across some personalities, people that are activists for body positivity, a social movement that strongly declare that any human has the right of having a positive body image. So all bodies, no matter the form, the size of the appearance, they have the same rights. We are now presenting the Lovewear, a project that aims at empowering people and their sexuality. So, of course, as I mentioned in the beginning, working with the inclusivity, we realized that there is a big taboo that, by the way, it's a big taboo for all abilities, which is sexuality. We are designing a product that through soft robotics empower people of all abilities in exploring their own body. And specifically, we started with people with limited movement, so people that can't really reach their own intimate parts. So through this system, which comprises an underwear, a device, and a pillow, and of course there is an application that controls all elements, helps people in exploring their own sexuality. This happens through a pillow interface. So while exploring the surface by touching or squeezing the pillow, something activates into the underwear. As you can see from this interaction scheme, there are some elements that are positioned on hips, gluteus, and the vulva. Lovewear, it's been a complex project. There are a lot of competencies involved in the project. We went through the understanding of sex toys available in the market, because we were not designing sex toys previously. We had to understand the physiology of the human body, pleasure patterns, the psychology behind people of all abilities. We involved the final user in a co-design phase. We had to deal with material engineering and different kind of engineers, electrical, mechanical, biomedical. Of course, an important part of the project was the micro integration of all the elements. And we developed this with a scientific partner, Fraunhofer IZM. And because of COVID or not, we had to face the virtual simulation, which was another important part of our work. And of course, fashion had a very important role in the project, since we wanted our product to be sexy and beautiful for everyone. So as mentioned, the first part was related to the mapping of sex toys, understanding what is available on the market, how does it work, which are the materials, which are the functions, how to use them. Another important resource was Oh My God, Yes, which is not just a website, but is a very important source of information. It's collecting the feedback of a very important research done on more than 2,000 women. And through this research, we could understand pleasure patterns. So every one of us understand more or less what you like and how you like to be touched. But of course, the product had to be flexible, and we had to understand how people in general like to be touched, and how people like to explore their own body. Of course, there was a very important role of the psychologist. We work with Paola Tomasello, who is also part of Lovewear, an association that supports the right of people with disability, especially rights related to sexuality. We prepared a questionnaire together with Paola that was translated in several languages. We collected feedback from people with disability, several disabilities. Some of them gave us the availability of being involved in focus groups. We had 2 focus groups with some people in which we presented our work. We got their feedback, and we tried to understand how to develop further the work. We interviewed some people, especially Ralph Eric Diggs, who is the founder of Sexuality, an organization committed to empowering people with disabilities, and Dr. Judith Glover, who is the founder of, I believe, the only course on sex toys design. I think it's the only available worldwide. So we got very interesting feedback. We got several feedback. A few of them are in these 2 slides. First of all, which are the areas where people like to be touched? This could be applied generally, I believe. But most importantly, in people with disabilities, I mean, it was just a confirmation of what we were expecting. So which are the main difficulties in having sex with a partner or practicing autoerotism for a person with a limited movement So of course, reduced mobility of arms and hands, and Generally, sometimes there is a limited genital sensitivity, and of course, manipulation issues. The use of sex toys is diffused, although there are difficulties holding sex toys or manipulating. Sometimes sex toys available in the market, most of the times, are difficult to hold if you can't really control your body. Anyway, of course, we started from people with disabilities, but we really wanted our product to be inclusive, so anyone could benefit from the product or use the product. So these are some use case scenarios. So Lovewear could be used individually. So you can just hold the pillow, explore its surface, and activate through inflatable pockets the underwear. It can be used with the partner, so the partner can control and interact with the pillow or the application and activate the underwear. Sometimes people with disabilities have a carer who helps them in the morning to get dressed and then comes back in the afternoon for shower or for daily needs. So the idea was to create a product that could be worn in the morning with the help of a carer, and then can be activated any time of the day whenever I feel I want to explore my body, or I want to enjoy Lovewear. The same thing happened with couples with disabilities. Sometimes there are couples with disabilities that are having difficulties in their sexual encounter. So there is a carer who can support them, helping them in getting dressed, or just holding the object, or anyway, the carer can support this. I will give the stage to Ivan.
Yeah, I would like to tell you a little bit more about our co-creation phase in Berlin hub, especially at Fraunhofer Textile Lab with Christian Dils and Aisung Kim. We were exploring different kind of textiles. So at the beginning, we really did a lot of different experiments on the use of textile that could be inflated and could be filled with air and other fluids in order to create this tactile effect. We kind of want to move away from the traditional or the more usual vibration stimulation, because we want to recreate a more natural feeling in the tactile experience. And definitely the pneumatics application are definitely underestimated in the use of wearable and in general in the use of technology. But they are one of the key points of soft robotics. So we see a very big potential in this kind of application, although the challenges are quite huge, because we need to cope between mechanics, pneumatics, and electronics at the same time. And that is not something easy. So it's kind of mechatronics, soft robotics, and mechanics and electronics all together. And that's posed some challenges, but through the use and the application of some virtual prototyping software, we were able to forecast how the fabric, inflated fabric, could move and could create some sort of dynamics that could be applied in our project and could be embedded in our project. And of course, we explore a lot of this gives us the chance to explore much more patterns and deformation than it could be possible in the actual physical experience, because it takes time to create this prototype, while virtually it's very easy to iterate and create a lot of different proposals. Of course, at a certain point, we had to go back to the physical model and prototyping. And we started in sketching on some elements, our channels and the distribution of the electronics and the inflatable pockets. We definitely did a lot of samples, testing different timing for welding fabric and with different technology, with the ultrasound welding and with heat lamination welding, using different typology of fabrics and try to understand how they could be made waterproof and airtight, and how they could inflate and stand the pressure, and how can we distribute this airflow inside the pocket that could then interact with the user and the wearer. And we came up in the end with this system of elements that are placed inside some pockets in the underwear, and a removable device that, of course, give the chance to the wearer to wash the textile element individually. It's connected to some attachment to the underwear, and it's positioned in front of the belly of the wearer. And the pillow, it's connected wirelessly to the device, and it's send the signal for, it interprets the movement of the wearer on the pillow, and then send the signal to the underwear for the actual feedback. These are some details of the inflatable elements that were manufactured in Fraunhofer, and then they were completed by our team of engineers that were creating the PCB and the element that goes into the shell that you have seen before, the touchable device. And that includes several manifold and several solenoid valves to direct the airflow into these different tubes and pockets. Here there is a very schematic view how the textile element includes, embed some cavities where the tubing and the electronics and the inflatable pockets are integrated. And we were working with a cutting edge company in the knitting business that use a specific kind of manufacturing process called warp knitting seamless. And this gave us the chance to produce at once, to manufacture at once a textile part that doesn't need to be stitched or doesn't need to be further finished, but comes off with all of the cavities and the tubing channels that needs to be used in our design. Now there is a short video that kind of demonstrates the use of our product. So
Thank you. I just need to cut in quickly because we're a bit over time. So
Okay.
if you could sum everything up in like 1 minute, and then we can
Yes,
move on
Yeah,
to
sure.
just the last few slides.
Just a few slides to show
Okay,
that the
thank you.
aesthetic aim of our work was also to create a new kind of lacing that has this sort of generative pattern. And here there are actual picture of how the product it could be once the wall elements are at the final stage, at the second iteration, and with the right finishing of the underwear and the right finishing of the device and everything in place. So this could be the actual picture that we want to achieve. Thank you for your attention.
Thank
And
you.
Thank you, Joanna.
Thank you, Team Witsense, Emma and Ivan. I really applaud how much you focus on inclusive fashion, and it's really great to see the results of this hard work in the last few months. We're going to start with the Q&A section. So I really encourage everybody to ask your questions in the chat or the Q&A function. But meanwhile, I would also like to introduce our scientific partners that we have here today. So as I mentioned, we have here Christian Dils. He studied microsystems technology at the University of Applied Sciences in Berlin and graduated in 2005. He afterwards worked for International Fashion Machines, Seattle, pioneering company for electronic textiles, and at the TZI Center for Computing and Communication Technologies in Bremen. In 2007, Christian joined the Systems on Flex group at Fraunhofer IZM in Berlin as a researcher for national and international projects. His research focuses on the development of stretchable and textile integrated electronics, especially for interconnection and manufacturing technologies. So, hi, Christian, welcome.
Thank you, Joanna, for the introduction, and hello to all the attendees. And Emma and Ivan, congratulations. I was really enjoying your presentation and also your achievements in the project. They're really amazing.
Thank you.
Thanks.
Thank you. We also have Dr. Max Marwede with us. He has been supporting companies in designing sustainable products through the facilitation of innovation workshops, the development of eco-design requirements, and through technology road mapping. And furthermore, he consults German and European public authorities on future eco-design regulations. As a researcher, he currently develops an easy and practical way to integrate sustainability into the product development process. So, hi Max, welcome.
Hi everyone, and thanks Witsense team for the presentation.
Thanks to you guys.
I would like to ask Anish, my colleague, if we got some questions meanwhile from the chat, from our attendees, from our participants.
So, hi everyone. So, while now I guess the audience is just trying to listen and get all the information from the panelists, and we don't have any questions so far, but just a question, well, I got curious, you know, like, so maybe something maybe for Emma and Ivan would be that, so how do you see yourself like after the Re-FREAM gets over to take your project? For example, now you have a good understanding of the prototype, you have it here, but for example, what are the next steps for you guys, like after the Re-FREAM?
Yeah, I think this was like a pilot project that opened up different chances in application in different fields, not necessarily the sex toys industry, but this gives us also a chance to talk about some uncomfortable sort of topics that is usually neglected from the society. And but definitely now we have video presentation, we have a product, we have a prototype, first iteration of the prototype in our hands. We have plenty of pictures that we can show on schemes, we can reproduce our prototypes and we can keep modifying it. We can test it on people. So these would be all the further steps that we need to achieve. And definitely we see as a viable option a crowdfunding campaign that would help us to materialize this journey into something that is commercially viable.
Great, great. And one more thing, because when you say like you want to take it forward, like it's just interesting to know, because you also did your research and you had like a lot of people to do the interviews. Which markets do you think could be a bit easier, like more or less, because you have certain restrictions, the culture? So for example, the European market, for example, so how it is right now to enter, for example, is it?
I think, you want to answer this question, or I would answer this question? I think you need really an open-minded market, and a market that is really keen on exploring, but at the same time, a market that could be receptive on these topics. Like, for example, I see European market is definitely our focus, but there are lots of differences in terms of different countries. For example, while running our questionnaires and the focus group, we realized that we got very interesting insight and very much openness from the Spanish market, from the people coming from Spain. They were much more keen on opening themselves and telling us the story of their sexual their sexual life. But in Italy, for example, the questionnaire, they were answering very briefly and very yes, no, maybe.
There were no details coming.
There was no lot of details, but from the Spanish participants, we got a lot of insight, and that declare the fact that some of the market are more receptive in this sense, and they are more open to also to try new things and to try this typology of product that doesn't want to position as a sex toy. So it's something, a sort of a hybrid product that want to position itself between a like a wellness sort of element of wearable that might blink at the sex toys user, but not necessarily could be bought in a sex shop.
But even location of the most important sex toys manufacturing companies probably says also about the market, right? Because in Germany there is a big manufacturer. In Japan, there is a very important factor. So probably there are also other markets to explore.
But probably also, yeah, in Germany and Japan, for example, if we can compare them, people from Japan are keen on using this kind of products, but very shy on declaring it and sharing their experience. While probably in Germany, it's slightly different. So there's in talking about this kind of products and this kind
interesting, because I'm doing a little bit of my own research, so it helped as well, you know, into sex tech. So thank you for that. We have a couple of questions coming from the audience now. So it's Jennifer from Basel. So she has a question from, I guess, for Emma and Ivan, that how did you like make your material or fabric decision? Did you do a research or a survey on the fabrics? So how did you come on a conclusion what you're going to use?
I think it's a lab work outcome. So it's we did thanks to Christian and Aisun and Valeria, our collaborators and the scientific partner. We did several iterations, like hundreds of iterations, using different fabrics, selecting initially which fabrics would work with inflation and welding. And this was our objective. And then try to understand also the specification of the fabrics that would be compatible, biocompatible with the human body and the skin, and especially the mucosa and the sensible part of the body and of the genitals. So these were selection through selection and research of products and different material available on the market.
I guess that answers Jennifer as well. We also have an interesting question from Ioanne. Maybe I'm saying it wrong, pardon my pronunciation. The question is that how did you find your technical partner? Like, how did you find Christian, basically? So when you applied for the Re-FREAM, so is it also like a process internally when you see a match in terms of your designs and the work which Christian is doing? So how did this match happen?
Well, I think this is a question for Joanna, if I'm not wrong.
Okay.
Yeah, maybe I can.
For the hub.
Yes, so as I mentioned before, in Re-FREAM we have 3 hubs. We have one hub in Linz, which is focused on 3D printing. We have one hub in Berlin, which is focused on e-textiles, and the one in Valencia, which is focused on sustainability. And we have technical partners from all over Europe that bring their knowledge, they bring their equipment, and they are part of different hubs. In our case, in Hub Berlin, as I mentioned, we have our partners from Fraunhofer IZM and EMPA from Switzerland. So the artists and designers that apply for the challenge from analog to connected have the opportunity to co-research and co-create with these technical partners. So I hope this answers your question.
Absolutely. Great. I guess that answers Shivone. Sorry again for my pronunciation. But yeah, so I guess these were all the questions we had from the audience, and also my questions. I guess they answered as well. So I guess it's back to Joanna now. And yeah.
Yes. Thank you, Anish. Thank you so much. I would also have, I would also like to ask you a question, because, you know, in Re-FREAM, we talk a lot about art tech transfer. This is one of the pillars in these projects. So I'm curious to see or to ask you, how did this, you know, because you bring artists and technologies together, which are 2 very different disciplines actually. So how did this work? How did these 2 different disciplines with maybe different mindsets benefit from each other? How was progress achieved, or did you learn new skills from each other? So I guess I'm addressing this question to everyone in the Q&A section.
Yeah, as we were saying in the presentation, the work behind the project is very complex, and it involves a big number of competencies and professionals. So actually, it's true, it's really challenging sometimes. You have to adapt your language, or you have to modify your mindset sometimes when you are dealing with all these different kind of professionals or competencies, you know. It's challenging, but it's also great. It's enriching you and your project. Sometimes there are some misunderstandings, you know, because we might not have the technical knowledge of understanding deeply some aspect of the project, or the technical partner. I don't know, maybe there are some things that are always working the same way. You try to find a different way to do something, and it's not understandable. So sometimes there are misunderstandings, but I believe this is the beauty of the collaboration. You really don't know where you will end up, but I think it's the greatest change of ideas and knowledge. And of course, in the end of the project, we enrich ourselves with a lot of different information. Even the virtual prototyping, for example, for us was a very important part. We could learn new skills, explore, and yeah, you know, it's also cutting the time of your prototyping because it gives you the chance to explore further. So yeah, a great, interesting collaboration with all these.
I think, no, just a very short sentence. I believe everything was there since Renaissance. So where the science and artistic skills were in the hands of one single person. So now what we are seeing, it's a new typology of Renaissance where this power, it's shared among a group of people, not necessarily one single person. So, and that is a kind of revolution that would definitely push further innovation. But I believe Christian might want to say something about it.
Christian or
reicht dann auch, wenn der Pfeil auf einer Seite kommt in deiner Skizze. Ne?
Actually, that was a really beautiful summary, because from my perspective as a researcher or technician, I made the same experiences and I had the same doubts as you had, just from the other side. So I think it was a very interesting learning process. And you have to adapt in terms of communication, in terms also of expectations. And for us, it was also really challenging because we never developed something in the field. So as you said, we had to leave our usual paths to find a solution. And yeah, we are really happy because the Re-FREAM project, it's about co-creation and stimulation for innovation together, and also for manufacturing. And I think we really achieved the results here in that project. Actually, in all three projects in the Berlin Hub, I'm happy. But yeah, it was great, and I'm really happy, thankful to the European Commission to have this kind of first art tech collaboration projects funded. Max? I don't know.
Would you like to add something?
Yeah.
Okay. We are a bit behind schedule, so I think we should continue with the next presentation. But I encourage everybody to keep posting their questions if they have any. You can also get in touch with our teams on our LinkedIn group, for example, or you can find details on our website about the projects and all the partners involved. My colleague Anish is gonna post again the link in the chat. Or just approach them now directly. You can send them a direct message. But I would suggest that now we move on with the second project that we would like to find out more about, which is Connextyle. This is presenting today is Jessica Smarsch, who's a designer with a background in textile design. After receiving a master's in social design from the Design Academy Eindhoven in 2015, she began focusing her work towards health and well-being, with a particular interest in health as a matter of the body and the mind. She began to narrow her work in 2017 towards stroke rehabilitation, and has been working in this domain ever since, developing a sensor garment and app for home rehabilitation. It's a very interesting project with really great results. So I'm gonna give the floor to Jessica so she can tell you more about it.
Hi everyone. Yeah, I thought what would be most interesting today is just to give everyone a sneak peek into the whole process that we've been through over the last, what's now been 11 months because of the extension. Because so much has happened. There's been so many different levels of research from both like a technical side and also from a design side. So what I wanted to do is take everything and put it into a sort of collage, and I'm gonna share that with you now. So please just let me know if there's any sound issues, if so I can try to change the way we present, but let's try it. It was a year ago when the Re-FREAM collaboration between Fraunhofer IZM and me began, I was very excited to have been given this opportunity, and I was also very curious to see what kind of developments could be made with my work in the months to come, both technically and aesthetically. Previous to our collaboration, I had been working within the domain of stroke rehabilitation, and I had specifically been working on a system which included a wearable garment capable of detecting muscle activity, as well as a feedback system which would allow stroke patients to receive visual feedback while performing daily activities in order to help improve their rehabilitation. This system was designed to be a creative exercise experience for the patients. Over the months that followed, I was traveling back and forth to Berlin every 3 weeks or so, and each time I visited, we had specific objectives, and we worked in the labs to create the different test materials. Our main goal was to create a textile integrated sensor for the collection of muscle activity, or EMG, which stands for electromyography. And this was really interesting for me because even though I had experimented with other methods previously, none of the methods I had used before were reliable systems. At Fraunhofer IZM, my tech partner Christian Dils introduced me to a technology and a product that they had developed there called TexPCBs. And essentially, a TexPCB is conductive material laminated between 2 layers of thermoplastic material, or TPU. The process of making a TexPCB involves laminating these layers one at a time in a heat press, and then cutting and peeling away the design that you build into the TexPCB. One of the first tasks at hand was to figure out which kind of conductive material would perform best for EMG measurements, and also determine the best design for the conductive track, which would need to stretch with the textile and not break or lose conductivity. Here you can see the first test that we did to understand if stretching the material had any impact on conductivity. Later, we performed these tensile tests to see how many stretches the materials could withstand. You can see that the material on the left was a non-stretch woven conductive fabric, and the straight track broke after 1 stretch. While the straight knit conductive fabric, seen on the right, was able to withstand 1,000 stretches, even though the TexPCB material became deformed afterwards. In the end, we determined that a knit conductive fabric was best, and that a wave design was good for allowing the material to stretch without becoming deformed. We also did conductivity tests after all of the stretching to see if the stretching had any adverse outcomes, but we did not find this to be true. After we determined the best material and track design, we tried lots of different ways to design the actual electrode, the sensor which would actually make contact with the skin at the muscle. We experimented with different conductive materials and techniques, and we manipulated the materials in various ways, all in search of finding the best technique for reliable EMG readings. Every time we made a new batch of designs, I sewed them into simple armbands so that we could perform actual tests on the body. All of the testing was done with a processing module from a company called I2M Medical, and the processing module is a very significant part of the process. With this project, we were able to identify a material combination that worked well together with this specific module. One of the biggest challenges is designing an electrode that can keep good contact with the skin. Another area of testing that we did in the lab was concerning how easily the laminated materials could be delaminated so that the product could potentially be taken apart and recycled after use. And we did find that the TexPCBs could be removed when the fabric was heated again. The first half of the Re-FREAM project was primarily focused on these areas of functionality, exploring the materials and designs for the EMG sensors. But I also needed to think about how these materials would work themselves into a functioning garment that could be used for the intended stroke patient. Since we knew that good contact to the skin was important, I began experimenting with different ways a textile could help to increase compression. So here's one exploration. I built off of this finger trap toy, which becomes tighter when stretched. This is a circular weaving technique that creates a diagonal weave. First, I tried the technique on a large scale using strips of fabric, and then I tried the same method at the yarn level. And then finally, I made a small sample to illustrate how a diagonally and perpendicularly woven fabric performed differently, which you can see here when I stretch the combined fabric tube. Another idea for creating compression was to create a 3D printed snap structure that could be used over top the sleeves to increase pressure in specific areas. On the left, you can see the different designs that I experimented with. And on the right, you can see how this idea can be used to create a three-dimensional shape. I designed and printed a 3D snap that illustrated how this could work. And even though we didn't use this idea for the compression garment, I used the snap technique later in the final design, which you will see. I began working with the Knitwear Lab, which is a custom knit development company in the Netherlands. They work on industrial flatbed machines, and they are unique in that they work with designers on small custom projects like this. We did a lot of material testing with different yarns and structures. One of the things I was very curious to test was knitting with a thermoplastic TPU yarn. We wanted to see if using such a yarn could improve the lamination process. And you can see that the orange yarn on the left performed well. It did not shrink, and it had a much lower melting temperature than the TPU of the TexPCB, which meant that we could laminate the textiles at a lower temperature, which is much better for the textile. As we began finalizing materials, Christian also made some first experiments to see how we could create an interposer connection between the textile PCBs and the processing module. In addition to creating the material, I also had to think about how to design the garment. I worked closely with Paula de Andres, a fashion designer in Madrid, and she helped in creating a two-part pattern in which we separated the technical sleeves from the rest of the shirt. The sleeves were the most challenging part of the design because not only did we want to create a pattern that would wrap around the arm and follow the paths of the muscles, we also had to create a tight fit and map out the areas where the TexPCBs would be placed. And this, of course, required a few iterations. And finally, we wanted to create a simple second layer shirt, which complemented the sleeves and which could be worn to create a complete look. It's also good to mention that through this whole development process, I have been working within a system of stakeholders, which includes the range of product developers that I've already mentioned, but also clinical therapists, healthcare managers, patients, quality advisors, business advisors. Developing for a medical application requires a team and a network. In July, we held a stakeholder workshop where the many stakeholders identified issues concerning the project, and then we broke out into small groups and discussed and mapped out potential solutions. As we approached the final month of the Re-FREAM collaboration, all of the final pieces began to come together. Working with Paula and Christian, we created and produced the final layouts for the TexPCB designs. What you see here are sensors for the shoulder, upper arm, and lower arm for measuring multiple muscles at a time. We created these simple armband designs to illustrate the final results of the research. And in these samples, Christian designed the interposer to match our processing module. And we bonded the interposer using this proprietary technique developed at Fraunhofer. The interposer is bonded to the TexPCB under extreme pressure. You can see how the pressure of the machine actually deforms the tracks of the TexPCB. Fortunately, this pressure has no negative impact on the conductivity. After the lamination, we tested all of the tracks with the multimeter and all connections were good. Here you can see the final research of the collaboration illustrated using the armband design. As you can see here, we use the lamination press to adhere the TexPCBs to the textile. After laminating the TexPCBs and interposer, we can attach the processing module. Here you see the simple armband design, and you can see the black module attached. The module and module clip is designed in 3 parts. A thin, snap-fit frame is attached to the textile. On top of the frame, a second piece snaps in, and this piece includes a rubber wall. This rubber wall holds the processing module in place. This design allows the module to be removed for recharging the module and washing the sleeves. For the final sleeves, I was able to work with a local company who has a very large laminating machine, which was perfect for the final designs. And here you can see the strange shapes of the sleeves and what the textiles looked like before they were sewn into the final product. So now I would like to conclude by presenting the final outcome of these many months of hard work and great collaboration. Okay.
Thank you. Thank you so much, Jessica, and really congratulations for this amazing projects and all the achievements. It's so amazing to watch everything that you and the team have achieved together. So now I'd like to ask again Christian and Max to join the Q&A section. And actually, Anish, do we have any questions from our audience?
So far we don't have any questions, but yeah, if they come up, I will knock.
Okay, don't forget to post your questions in the chat or in the Q&A section. And as you see, our team can answer them. I mean, the team that worked on this project can answer them directly. But maybe in the meantime, I can ask you, because you know, when we talk about fashion, we really have to talk about sustainability. So which role did sustainability play in your project? How did it influence the development of it and the final results?
Well, I would say, I mean, of course, we did look from a material point of view. That's the reason for doing the test with removing the lamination. So that was just to see about how we could separate for recycling. I also, you know, we did a lot of material tests when I was developing the materials with the Knitwear Lab. So we looked at what kind of yarns might have a sustainability story. For example, one of the yarns is biodegradable. Yeah, and then I mean, I think also if we can like include, you know, social sustainability. I mean, that's a big part of the project for me, in terms of creating a medical device that doesn't draw attention to the problem. So really trying to create something that helps people and also makes them feel good while they're in the process.
It's Max, please. I see you want to add something.
I think it was really interesting also to develop the stakeholder workshop together, because one part of the stakeholder workshop was also looking at the overall sustainability of the system, which means basically how is the product used, can it be reused, which requirements does each stakeholder has to fulfill in the overall system. And it's really a complex system, because in a medical tech, of course, you have many stakeholders involved, such as the rehabilitation centers, the therapists, the patients, but also there's many standards requirements you have to fulfill. So from that point of view, this ecosystem design was an interesting part for me.
Mm-hmm. Thank you. And Jessica, because I mean, you have worked a lot. You have put a big focus on being in touch with the stakeholders of this project. So what was how do you think this influenced the perspective after Re-FREAM? Do you see a perspective of pushing this to the market, or how would you see this? How did it influence, and where is it going?
Well, I think where it is now is really starting to feel a lot more tangible and approachable to many of the different stakeholders. From a usability point of view, that was a big issue I wanted to address, and I think that by separating the shirt into a sleeve component and an overlayer garment, and even just offering the armband design for certain applications, it simplifies the product. It makes it easier for people to use it, and also it's more clear now a path to how the product could actually be manufactured, even though there are some links missing because of this being a very new technology. Yeah, some of those question marks start to become much clearer, and I think also the story becomes a lot clearer. And I've already kind of, been getting response to like the little bit of, material that I've started to put out there. So let's see.
That's great. We're keeping our fingers crossed and are gonna definitely follow the evolution. Anish, do we have any questions meanwhile from the audience?
So we have Jennifer again from Basel, I remember. So she's asking a question now to Jessica, is that the sleeve which you mentioned, which was the most difficult part of the process, which you already mentioned in the presentation. So how actually is it connected with stroke rehabilitation? And are these actually vibrating, or what is the mode of it? So that's from Jennifer.
Yeah. So if you're really curious about it, I have other projects on my website which go into more depth about the process of the rehabilitation. For this presentation, I really just decided to focus on the product, but what it's basically collecting, it's a collection device. It's collecting the energy from the muscles. There's an app that I also have created in earlier projects, and the app is processing the information, and it's generating feedback so that when patients do exercises, for example, if they move, they'll see a visualization that's following the movement of their arm. And there's specific exercises in the app that encourage the patients to move in different ways. So yeah, it's not stimulating the body, it's collecting data and translating that into feedback.
Great, I guess that answers Jennifer as well. And also, like, if Jennifer, you want to know in detail, you can contact Jessica herself. And maybe you can join the LinkedIn group where you can actually meet Jessica. So that could also be interesting for you to go into detail, because yeah, we cannot talk much into technicalities in this one. But yeah, thank you. And yeah, Ioana, back to you. So I guess.
Thank you, Anish, for interacting so nicely to our attendees and the rest of the participants. And thank you for asking questions actively. If there's anything that pops up, please feel free to keep writing in the chat. And in the meantime, I have a I have a question, sorry, addressed to the team. It's actually very similar to what we previously discussed with Team Witsense. You bring this, these two very different disciplines together. And I would like to know how, what your learnings were in this project. Which new skills did you learn, or how did you benefit from each other in this sense, by bringing art and technology together?
Maybe a compliment to Jessica, because it was really easy to work with her. I sometimes was feeling, is she a designer? Is she an engineer? Like, because of the way of thinking and quickly understanding technical issues or difficulty or challenges, I think we were like very often on the same level. She came up with so many interesting ideas we haven't thought about when we developed the TextPCB technology. So we were really like, I think it was a really great example of like stimulation for both sides, also improving the technology, and finally, her project was also really well timed for us, because we built up and developed manufacturing technologies for stretchable electronics for a while, and we just added the TextPCB technique to that portfolio just before Re-FREAM, and it came out, it was a perfect choice to realize her application. And it's also interesting to now to use this results to get the industry, to get the technology out in the industry, yeah, by using her final results to gain interest for the technology, also to maybe transfer the technology industry. So yeah, it was really great. Thanks, Jessica.
You're welcome. Yeah, I mean, it was also a pleasure to work together with the team at Fraunhofer. Yeah, I think what is also can be challenging when you bring art tech together is do you understand each other? And yeah, I also think that we worked really well together, and you know, I think it's a matter of just being able to explain things, work together in a way that you can, you know, find common ground. But we really didn't have a problem with that. I learned a lot. Some things, like, you know, there were times where I just said, like, I really don't know what you're talking about, you know, like, and then we would sit down and show, and then, okay, clear, you know, and yeah, it was a really nice learning experience for me.
Thank you. Anish, are there any more questions from the audience?
No, so there are no questions so far. So I guess the only one was Jennifer, so.
Okay. Since we are a bit over time already, I would like to suggest to everybody, if you want to get in touch with any of our panelists, you can find get in touch with them on LinkedIn, join our group. and continue the conversation there. Also with other like-minded individuals in the industry. I would also like to congratulate the teams for all the achievement in these months. I really saw the progress from the beginning until the end, and they did such an amazing job. They really worked hard and they put their hearts and souls into these projects. And really congratulations from our side as well. It was really a pleasure to see the involvement of the projects. And I would like to invite everybody else who wants to have a similar experience and develop their projects, their idea maybe to a stage of prototype, to apply to the second call in the Re-FREAM project. I'm gonna quickly share my screen and tell you a bit more. So, you know, in Re-FREAM, as we mentioned, we want to co-explore digitally enabled small-scale production or manufacturing systems with artists or designers, and we really invite the teams to work together to co-research, co-create, to to develop these projects. The co-creation is happening over a 9 months period, and the second call is actually running right now until the end of the month. So you can still apply, go to our website, check it out, and maybe you will be the next selected artist, and we can hear about your ideas in a year's time. So I would really like to thank everybody for your participation today and for your contribution. I'm really looking forward to staying in touch and seeing how the projects are gonna keep evolving, because the potential is definitely there. And yeah, thank you.
Thank you.
Thank you, Anna, for the moderation.
Thanks.
Good luck to all the artists and continuing. Guys, I already start missing you after that intense time. So let's keep in touch. And again, congratulations. Both presentations were super.
Thank you.
Thank you.
Okay.
And thanks, Joanna and Anish.
Thank you also to our team. Thanks a lot, and keep in touch.
Thanks and goodbye.
Okay, bye.
Bye-bye.
Bye-bye.